G'day, I'm Mark Hoth and welcome to Swift Almanac, where we teach you the basics of Swift in 10 minutes or less. Today's lesson is classes and structures, and classes and structures allow you to combine properties such as variables and constants with the functions or methods that use those properties, which keeps your code clean and manageable. So let's have a look at classes and structures in 10 minutes or less. Classes and structures. These are data types that we create that allow us to link properties such as constants and variables with functions, which we call methods, or subscripts, initializers, and some Swift functionality called extensions and protocols. Now, both classes and structures have the ability to do all 6 of those things. In addition, classes are able to provide inheritance from a superclass, and type casting checks can be done on the class at runtime. That is, while the application is running, you can check that a variable is of the correct class. Classes also have deinitializers, and that's because classes use reference memory and structures use value memory. And for the same reason, classes require reference counting, which allows more than one reference of a class. So to define a class, we use the class keyword, and then we put in some properties, some methods, initializers if we want them, etc. And we've got other tutorials on all of that functionality. If we want to define a struct or a structure, we do the exact same thing. So classes and structures, once defined, are available within the scope of the project. That is, any source file can access that class or structure definition. Classes and structs, once defined, create new data types within Swift. Hence, the name of the class or the struct should commence with a capital letter, and all the properties and methods should commence with a lowercase letter. Let's look at an example. Okay, so here we have a structure called resolution, which has 2 variables, width and height, both of which are inferred ints. And we have a class, a video mode, which has a variable resolution, which refers to the structure above. And then it also has an inferred boolean, an inferred double, and an optional string name. So let resolution equal resolution, and let some video mode equal video mode. Now, by default, classes and structures are given default initializers based on their properties. And to access the properties or the methods, we use the dot notation. So some video mode dot resolution dot height equals 720. Some video mode dot resolution dot width equals 1200. Now, for structures, the compiler will create these member-wise initializers whereby you can simply type and we get this width or height option, and we can change that to 1920 and that one to 1080 for high definition. And let's create a cinema. Now, the thing about structures is they're a value type. So when we assign one value type to another value type, we are copying the information from one to the other. We are creating a duplicate. So if I then change cinema.width to 2048, and if we print hd.width and we print then we will see two different values, and that's because they're at two different memory locations. Classes are reference types. When a class is assigned, a reference to a memory location is passed, not the contents of the memory location. So the typical example is if you have a house and the house is at 10.10.1 infinity loop, then you have the reference, the address of the house, but you don't know whether the house is a 1-bedroom house or a 2-bedroom house or a 3-bedroom house. But if you say to someone, meet me at 10.10.1 infinity loop, they're going to go to the same location as you're going to go, and when you get there you can find out how many bedrooms that house has. So let's do an example. Let 1080 equals video mode. 1080.resolution is HD from above. 1080.interlaced is true. 1080.name is 10.0, let's make it 10.10.1. And 1080.framework is 25. Now let's create another reference called also 1080, and we're just going to set that equal to 1080. So also 1080 has the same reference as 1080. That is, they're pointing to the exact same memory space. So if we set also 1080.framerate to equal 30, and we print out both of those values, when we print them out, they both change to 30 because they're pointing to the same address in memory. Okay, now note here that 1080 and also 1080 are constants. We've used the let keyword to create constants, and that's referring to the memory reference, which will remain constant. But you can still change the property values that that memory reference points to. So for instance, in our example of the house at 10.10.1 Infinity Drive, if that was a 2-bedroom house, we could demolish the house, we could put in a 3-bedroom home, and even though it's changed from 2 bedrooms to 3 bedrooms, it's still at the memory address of 10.10.1 Infinity Drive or loop or whatever I said. Well, hopefully that's clear. In addition, Swift has an identity operator, and you can check to see if two class data types are identical or not by using the triple equal sign or the not double equals operators. So you can say if 1080 is equivalent to also 1080, then we can print identical, and when the playground runs, it will print identical because they are. So when do we use classes and when do we use structures? Basically, structures are designed for simple things, points, 3D space, etc., where there are only a few properties and you probably don't need any methods at all, or very few. Just use them to keep the data together, or if you have a short-term need. Use classes for everything else. More permanent memory use. Swift uses structures for string, array, and dictionary data types, and that is different to Objective-C, which uses classes for NS string, NS array, and NS dictionary. Check out the other tutorials on methods, subscripts, initializers, extensions, and protocols, and also in relation to classes, check out the tutorials on inheritance, typecasting, deinitialization, and reference counting. Well, that's it for classes and structures. I hope you understand the difference between classes and structures and when to use them. If you have any questions about the tutorial, then please leave a comment below or hit me up on Twitter @SwiftAlmanac. Please subscribe to the channel, it's free, and check out our website at www.swiftalmanac.com. Thanks for watching, and we'll see you next time. Cheers.